Now we're ready to move on to practice questions. We only have 3. I'm going to walk you through some parts of them and leave some parts up to you to do the thinking through for yourself, but I'm going to guide you through some of the review stuff you need to be successful on those problems and also on IXL, which is going to be coming up next. So I'm going to go ahead and share my screen and we will get started. So I am at Deliverable 2, which is your practice questions. We're going to use the 6-step method you just read through on the previous page to separate this triangle diagram, these stacked triangles. And in order to do this, we have to look at our given and our proof statements. So given that line KM is perpendicular to line LN and line LK is perpendicular to line LM, prove that triangle LNM is similar to triangle KLM. So we're comparing this one right here to the big one. All right, so step 1 in this process is make a list of the 3 triangles in the diagram. So we have triangle, let's list the big one first, KLM. Okay, we've got triangle, let's do the medium one next. We've got MLN. Whoops, MLN. And now the small one over on the left, we've got triangle KLN. Okay, that works. Now for step 2, we're going to redraw the original diagram and mark it with given information. I am not going to redraw this diagram because it would be a pain, but you should on your piece of paper. And then to mark it with our given information, we're first given this piece. KM, line KM, is perpendicular to line LN. So these 2 lines are perpendicular. That means there's a right angle here and a right angle here. Okay, so we've marked that. Next is line LK is perpendicular to LM. So here's LM, here's LK. Perpendicular means right angles. So I put my right angle marker in there. All right, so that's step 2. Step 3, we're going to draw 3 separate right triangles, all pointed the same direction, labeled with the angle marks from the original diagram. So for this, I am going to pull up a screenshot I took where I actually put in some triangles already, because that's going to be helpful for me. So I'm going to clear my drawings for now, and we're going to look at it on this piece. Okay, so here are my triangles that I've drawn. I'm going to start by putting in my right angles from my original diagram, which remember were right here. So once you've drawn yours, they can be oriented any direction as long as they all match. I put my right angles down here. Okay, so I'm marking my right angles. So it says draw 3 separate right triangles, all point in the same direction, labeled with angle marks. Those are the only angle marks. 3 right angles is all I have. So step 3, I'm good. Okay. Now step 4 asks us to label our separate diagrams with the letters and marks from the original diagram. So we're going to take the letters from our original diagram and put them here. Uh-oh. My precious right angle marks, what happened? This is weird. Okay, anyhow, here's my right angles. Okay. So in the large triangle, my right angle was up here. How many times could I redraw it? L. Large triangle, my angle mark is L. Okay, what about in my medium triangle? In my medium triangle, my right angle mark is at N. In my small triangle, it's also at M. Okay, so we want to start with the right angles. That's the easiest to see. Next, we're going to label the other vertices And the way we're going to do this is we're going to look at what triangles have shared corners. So in this medium triangle right here, and in the large triangle right here, M is in both of them. So I can choose in my large triangle how I want to label it. If I put it up here for my large, I'm going to put it up here for my medium, because those are a shared angle. It's the same. The reason they're the same is the reason something is congruent to itself is reflexive property. Remember, when you look in the mirror, it's your reflection, reflexive property. Something is congruent to itself, okay? So I only have one letter left to place for the large triangle. So I'm going to go ahead and label the rest of my large triangle. I have L, M, and so I guess K goes here. It's the only spot left, and it's definitely part of my large triangle. But if I look at this small triangle, it shares K with the large triangle. So K needs to match on the large triangle and the small triangle. They need to be in the same position. Again, because of reflexive property. K is the same angle, whether it's part of the small triangle or the large triangle. It's just one actual piece, part. Okay, now I just need to fill in my medium and my small triangle. My medium triangle, I know it's N, M, L. I can also look back to my list from step 1. And my small triangle, I know it's N, K, and L, and I haven't used L yet, so I'm going to fill that in. So now I have reoriented and unstacked all 3 triangles here, and I can make easier comparisons. All right, let's go back to what our next step is. Our next step was make any other marks in your diagram. You don't have any of these from your original diagram. We only had those right angles that, again, went missing off mine, but you have them on yours. So there's no other marks we need to make, so we can skip this step for this problem. Step 6 is choose a similarity postulate, and in complete sentences, explain why this postulate and the marks in your diagram prove triangle LNM is similar to triangle KLM. Remember, this is what we were asked to prove. And don't forget, this symbol means similar to. So it might take a minute to think back to our similarity postulates. You should have thought about them some during the warm-up, but our similarity postulates are AA, which is angle, angle. And for these, we have two pairs of congruent angles, and it's 2 pairs of corresponding congruent angles, actually. Okay. We have SAS. This is side, angle, side. In this similarity postulate, we have 2 corresponding proportional sides with an included congruent angle. And think back to in class, we learned that included means between. So that included angle is between the 2 proportional sides. Think about if you make a sandwich and you include tomatoes in your sandwich, the tomatoes would be inside, just like that angle is inside your 2 proportional sides, okay? And then we have SSS, which is side, 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 and that involves 3 pairs of corresponding proportional sides. That means all 3 sides of each triangle correspond to another part and are proportional. So which of these postulates, look back at your diagram that you marked, which of these postulates prove these 2 triangles are similar? You're going to think that through for yourself and explain in words how you know these 2 triangles are similar and by which postulate. So if you need to spend some time doing that, which you should, pause the video, and when you're ready, unpause, and we'll go through the next question together. All right, so I hope that you thought that through. If you have any questions, come to office hours. Happy to talk about it. Now we're going to do question 2. This is now thinking about balancing proportions. which is one of the pieces of our notes. So it says, use the triangle diagram below to answer a series of questions. Part A, write a balanced proportion of the sides of the two triangles above. This should not include numbers. Use the letters to name the sides. So I'm going to show one example, but one of the cool things about proportions and using them for similar triangles is that there's so many options. So ideally submit a different option for your own work than what I'm going to show you right now, but use the same sort of method of how we balance proportions. Okay, so I'm going to start by saying AB. That is my big triangle's left side. AB over, let's do AB over ED. ED is the left side of my small. So these are both left, so I'm going to call it L for left. I'm going to say that's equal to, remember when we set proportions, we make two fraction bars like this. I'm going to say that's equal to BC. That's this big hypotenuse over EF. That's my small hypotenuse, EF. So these are both the hypotenuse, and AB and BC are both part of my big, and ED and EF are both part of my small. So I'm comparing my big left to my small left and saying that is equal to my big hypotenuse over my small hypotenuse. So it's completely balanced. There's no mismatches there. Can you think of a different proportion that still works and is balanced, but isn't this one? Pause, give it a shot. Next, we're going to take a look at number 2. Is this proportion, or part B, is this proportion balanced? I think you guys can handle this on your own. Is it balanced? Why or why not? Give it a shot. Part C, are the two triangles similar? Remember earlier in the video when we went through the different postulates, look back to that list and decide, are they similar and by what postulate? These two questions right here ask you to think about the similarity ratio. How many times bigger is this ABC triangle compared to DEF? And how many times smaller is this small one compared to this big one? You guys got this. I do want to take a quick look at number 3 together. You're going to get a lot of questions using this skill when you go to IXL. So I want to make sure we have it covered here so that you can practice on your own more on IXL. So for this question, I notice right off the bat that I'm asked to solve for QR. That's my question mark. But I also notice that these triangles are not oriented the same way. So I immediately think I've got to reorient and redraw my triangles so that the right angle is in the same spot for them both. I'm going to do that here. One of them is looking bigger than the other, so I'm going to show that in my drawings. Okay, I'm going to draw my right angles in, okay, and I'm going to go ahead and label with letters what that is. So for the smaller one, it's P. For the larger one, that's X. Okay, from P, I'm just going to copy this over, P, R, Q, and I have 5. Let's see, this is 5x plus 2, and this is 21. So you just need to redraw and relabel. I also need to make labels on my letters for my angles. So this one has a single hash mark, this one has a double hash mark. Okay, now I've basically flipped a reflection, this, so that it faces the other way. X stays in the same spot, but I need to make sure that everything matches and they're oriented the same. So I need to put whatever had double hash marks right here so that this matches, and that goes with letter Y. So I had a few things happen here. not just a basic flip. I have y. Here I'm going to have the one with 1 so that it corresponds to this angle, and that is z. Now I'm going to put in from x to z. X to z was 28. I need to be careful when I copy this down that I just don't put it in the same position. I need to look at my letters, x to z, and then z to y, that's 7x. Okay, now I have everything oriented correctly and relabeled. From here, what I do is I set up a proportion, and I want to balance my proportions still. So I'm going to start with my small left, 21, over my big left, okay, 28. I'm going to set that equal to, so I started with small on top. I'm going to keep small going. So I'm taking my other information I have for small, 5x plus 2 equals, and large was on bottom. So I'm going to take my other piece of large information and put it here. This works because these sides correspond. These are both my hypotenuses over here, and these are both my left sides over here. I've got small on top, big on bottom. From here, I can cross multiply to solve for x. So set up an equation where you set 21 times 7x equals 5x plus 2 times 28. Make sure you follow PEMDAS. You'll be able to solve for x. Don't forget, you are asked to solve for the length of QR. So once you find x, you're going to need to go make sure you solve for what the question asks you to solve for. Once you're done with this, you have one more thing to do today, which is going to be IXL. I hope it's going to be really fun for you. I'm going to make one quick video about how to navigate IXL. If you have any questions about it or about this work, please log into office hours or email me and Brock. We're really excited to help you make this review successful and help you boost your grade.